Okay, let's do this one. This one presents a new challenge for us, okay? So, first of all, toolbox. Write everything in terms of sine and cosine. Also, sorry, I should mention this. I gave the people that are here in the room a chance at this. So if you don't want to hear me talk about it right away and you want to see what you can do, I absolutely would encourage you to do that. Just pause the video and then come back and get the explanation. Like, write it down and be like, I want to try this and see what I can do, because that's the only way. And I think I mentioned this in class to yesterday's class, and I don't remember if I put it on a video or not, but it's like, what typically happens every year is like I talk through how to do some of these problems, and everybody's out there in the audience saying like, that makes sense, okay, I get it, okay, I can do this, this is easy. Then you try to do one by yourself and you can't. And I'm not trying to set you up for failure, I'm just saying, it's totally different when you have to come up with all the ideas and it's not me just talking about it, all right? So, pausing it and trying it on your own is a good idea, all right? So, let's look at this. The way this is set up, we have our sines and cosines. Do we have squared terms? Yes. Okay. Could I do something with this? Sure, I could do something with that. I could manipulate the Pythagorean identity and get sine squared x by itself. I could do that. So it's an option. I'm not going to cross that off the toolbox. The third option says factor, common terms, or the difference of squares, right? There's nothing in common here. However, and this is where the new stuff comes in, right? Here's a couple of things that I've said before and I'm going to keep bringing up. We have to be able to see the trigonometric package as a variable, meaning this is sine fourth of x. That would almost be like u to the fourth power. What if I called sine x u? Okay, stay with me for a second. Okay, then this, if sine of x is u, and I have 4 of them here, right? I have 2 of them here. Then this is 2u squared, like so. And what can we do with a 4th degree trinomial where the middle term is half the exponent of that, and there's a floating constant? It might help if I rewrite it where that's in front, and since these are both positive, I'm just going to flip those two. If I wrote it like this, what can I do with that, right? An even degree trinomial. So I can factor this into binomials. And I realize I've kind of shifted into this single variable idea, okay? But if it helps to visualize it like this, at least in the beginning, let's stay with it. So remember that whatever this is the variable that goes here. U squared times u squared is u to the 4th. 2 numbers that multiply to be positive 1 and add to be negative 2 are negative 1 and negative 1. So really, this expression could be factored into, what did we say u was? We said u was sine x. Could be factored into sine squared x minus 1, sine squared x minus 1. And this entire time, I realize I've left cosine to the 4th x all alone, okay? And just as a word of advice, you're trying to simplify, so starting with the side that's the simplest isn't always the best option. That's why we attack the side that looks the worst first, okay? Now, when we look at this, so we factored, right? We did some, and it's not technically u substitution. Calculus kind of has a copyright on that, but we used a single variable to represent sine x, which made it a little bit more palatable, okay? And then I even switched these around to write that in descending order like we like to see, I think. But you don't have to do that, okay? Anyway, we get to this point. Now the bells and whistles should be going off in your head when you see this, right? So we go into the margin and we figure out how we can get a statement that says, how we can get a statement that says sine squared minus 1. Sine squared minus 1 means I need a minus 1 over here. But if I want the statement to say sine squared x minus 1 equals, then the cosine squared x needs to come over here. Okay? And I realize I'm doing both of those at the same time, but I'm getting rid of the 1, but bringing over a negative cosine squared x, like so. So this is equivalent to this. And when I come back into my proof, now I have negative cosine squared x equals positive cosine to the 4th x. And a negative times a negative is a positive. So there you go. Okay? So, factoring a trinomial, an even degree trinomial. Right? It's a very specific case. In the toolbox, I wish I could just put factor. Okay? And I probably could, but I try to add a little bit of detail to that to help you guys out. I think we'll do another method here in a second in a different video. Something else to chew on.